Good morning to everyone. So today topic is the grammar in Automata. So before going to the topic, so everyone know about what is a grammar. So grammar is a rule for generating a or make the strings of language, that is known as rules. That is known as a grammar. For example, in English we follow so many grammar rules. When creating a sentence or when creating a paragraph, we follow the rules. The same concept, we have more languages in Automata. Some example, finite Automata accept the regular language, then context-free language, regular expressions. So we have so many languages. So when make a language, when generating a language for Automata, we follow the grammar. So grammar is nothing but a set of production rule which make the strings of language. So the set of all possible strings in a language which can be derived from a grammar. The set of all possible strings which can be derived from grammar, this is known as language of that grammar. The set of rules, that is known as grammar. So after that, what are the elements used to make the grammar rules? So this is the 4 parts in grammar: the name of verticals, terminals, production rule, and S for starting symbol. So elements of a grammar that depends on types of a grammar. So this is the basic elements. Grammar G is equal to the combinations of verbals, terminals, production rule, and S. S means the starting symbol. So what is verbals? So verbals is nothing but a capital symbol like A, B, C that represents in the slide. So this is a non-empty set. So the terminals must have values, some strings, that is known as a terminals. So that is represented in capital letters A, B, C. So this A, B, C's are used in our production rule. Okay, so both verbals and the terminals both are used to create or generate the production rule. The second one, T, represent the terminal. So this is also a finite set of alphabets but presented by small letters. Small letter A, B, C, X, Y, Z, like that. All variables are replaced with non-terminals through the production rule. So these verbals can be replaced by using verbals, capital letters. The small letters can be replaced by capital A, B, C. So this terminal is also part of production rule. The third one, this is a production rule. Here I write some example. So S tends to A, S, B. So the capital letter S tends to small letter A, capital letter S, small letter B. That means A, B are terminal, S are non-terminal. So this is the production rule format. Production rule S also may be epsilon, may be empty. So that means the production rule on left side must have some verbals. Some must have some verbals. On right side it may be empty but non-empty in left side. So everyone know that S means the starting symbol. So that is used to start the production rule. So it's represented by capital S. So see the example number 1. We want to construct the context-free grammar for the language. We construct the context-free grammar for the language having any number of A. Having any number of A. So the given language have a symbol only A. By using this symbol, you can generate many number of strings. But the strings must follow the rule number 1 and rule number 2. Okay. The first S is a starting symbol. It tends to small letter A, that means terminal, and one more non-terminal, that means verbal. So the production rule first contain S tends to A, yes. So non-terminal is tends to combinations of terminals and non-terminal. This is rule number 1. The rule number 2, the string, the starting symbol yes may be empty, may be epsilon. Okay, so my language contain only one symbol. Using this symbol you can generate many strings by following rule number 1 and 2. So considering this is a small example, number of A's repeating 6 times. So this is a one of language. So one of strings in my language. Okay, how can I generate the strings? So this is the step to generate the string. So our starting symbol yes, yes can be replaced by a yes based on our rule number 1. Yes non-terminal can be replaced by a yes. So again the last digit yes can be replaced by a yes. It repeated many times, up to 7 times the yes can be replaced by a of yes. The last yes can be removed by substituting epsilon. By substituting epsilon, here only we follow the rule number 2. So now I generate the 6 type of A. 6 times the A is repeated. The strings contain only A. The number of A is not a problem in the strings. So now I generate 6A in my language. So this is the way of to generate the strings. So in our example, the symbol is given, the regular expression is given, the grammar rule is given. This is a 2 rule. So based on the symbol and the rule, we generate many strings in the language. Just we substitute the values on right side only. So when we go to example number 2, so we generate the regular expression 0 plus 1 star. That means number of 0, number of 1 repeated many times. Okay, number of 0 or 1 repeated many times. In push down automata, in finite automata, any automata plus mean nothing but or symbol. Both 0 or 1 any can repeated in many more times based on this closure properties. The star is point repeated many times. Both 0 or any 1 repeated many times. This is the rule number 1. Rule 2, the production rule 2, S tends to epsilon, S may be empty. Okay, so by combine this 2, so what are the elements present in the language? 0 and 1. So what is the rule? S tends to 0S or S tends to 1S or S may be epsilon. So we can make a expression.